right, so gas laws. Now remember how gases are made up. Gases are made of particles that are spread out. You can compress them and things of that nature. And so what's cool about the gas laws is that they're predictable. Okay, they're predictable. So if you have a change in temperature, the gas will do something. If you have a change in pressure, something's going to happen. If you change the volume, there's going to be a change, or in the number of particles, and it's all going to cause the behaviors of gases to change. So we're getting ready to get into those, but I wanted to just lay the groundwork right now. Now, before we get into it, I want you to understand what is pressure. We use pressure in a lot of different ways. You could use it as you got homework, it's due, and there's pressure to get it done and turn it in. But the pressure that we talk about in ICP, the pressure, I want you to think of it, it's a force, okay? Pressure is a force, and it's always going to be applied to a perpendicular structure. So if this is the area, it's going to be applied down perpendicular to it. So like if I put force down on my arm, my finger is perpendicular. You can actually see it bend my arm muscle down. And so that's what this here shows. Another way to think of it is, you have a tack in here, and here the area is much bigger, and so you can press down on it. But here, the area is not as much, and so if you keep doing that, the pressure here is much greater than the pressure here, and it's going to poke a hole through your body because that area there is so small, compared to up here, the area up here at the cap, that's humongous, but down here it's not. So whatever force you put down or apply up, it's going to be magnified right there. Now, cool thing is, and I had tried this one time, I've laid on a bed of nails. This looks so painful, but it's really not that horrible. Now, I remember growing up, I would get a nail stuck through my foot every once in a while, not paying attention where I was walking. That was quite painful. And you would think, well, you step on this, it's just all these are going to go through your feet, but that's not the case. Because, even though you take one spike, remember that we go back to this pen drawing, that spike is just a small area and your weight is down on it. But now look, it's sharing it with like 1,000 different nails here. So you could actually walk on this. Probably wouldn't be absolutely like the most comfortable thing, but you can see you would have to really put a lot more pressure perpendicular down on his feet to actually damage his feet. And the nails are kind of coming up, applying a pressure perpendicular to his feet to keep him up and above. Again, probably not ideal, but makes for a good story if nothing else. Now, the formula for pressure. Pressure is equal to force divided by area. Okay, and that's that perpendicular. Here's our friend, the square, or this triangle here. And remember, here's the pressure, and so force, how hard are you pushing, is divided by the area. And you could do simple math calculation. I don't think we're going to do that, but you can actually figure it out. And it's easy if you have, a perfect, a pretty square material that you're weighing and a means to weigh it. And so you might see this formula in a test. I don't think that I'm going to have you solve it. Okay, so what causes pressure? What causes pressure? Well, in a gas. What causes pressure? In a gas. Well, here's our gas. And remember, gas can be compressed because the particles are far away. Remember, they're energetic, and this energy helps them overcome their attraction to each other. But what causes the pressure? Say like in a tank of propane or a tank of oxygen, or in that tank that you saw just explode, that oxygen tank, it is the more you stuff in here, the higher the pressure goes. So what you do is you put in the number of particles, you're increasing that number of particles big time, and then that means there's more particles that are going to strike the container wall. And remember, gases, they're moving about 900 miles an hour. And so everywhere they strike the container wall, there's pressure, there's pressure, there's pressure. there's pressure. It's no different than walking up and pushing somebody. You know, you're applying a pressure and they're going to react accordingly. So the more particles you put in it, the more pressures there's going to be. Okay? Now we're going to talk about, there's other ways to affect the pressure of a gas. Okay? Factors that affect gas pressure. Well, temperature. I've noticed this. You don't want to leave a spray paint can in a hot car because you're going to force those particles to move faster and faster and faster. The can may not hold. And so what we've learned about temperature, you guys have already mastered this, that the colder something is, the slower the movement. So all those particles hitting the side of the container, if they're cold, that's going to force the pressure to drop. But if you increase the temperature, the pressure is going to increase because the particles are speeding up. So remember, here the pressure is going to decrease because the particles are slowing down. They're not hitting with as much force. But if you make them hotter, remember you're adding some energy into the system. It's going to increase the pressure because the particles speed up. Next one, volume. So how does volume increase or affect the pressure? Well, I told you in the oxygen tank, if you keep pumping oxygen, pure oxygen in, it's going to come a point where it won't be able to take the pressure and the tank will explode. So, you know, when you think about volume, volume is the amount of space something takes up, right? And so if you have a volume of gas and you decrease the volume, what's going to happen? If you increase the volume, you're going to decrease the pressure. So think of about it as having a balloon. Then all of a sudden, the balloon actually gets bigger, but you didn't change the amount of gas in it. The balloon is going to go from being pretty tight and round, and it's going to be big, but it's going to be, you know, really floppy, loose kind of looking. And so whenever you increase the volume, you're giving the gas more room to move, and it becomes less tough. They call it turgid. And so that's going to decrease your pressure. But if you have that same balloon and you try to squeeze that gas down, you'll notice that sometimes if you have a balloon and you squeeze it, part of the balloon will squeeze out of your hands, and it's much higher pressure in that section of the balloon. And so if you reduce the volume, you're going to increase the pressure in it. When you go get a tank full of propane for your grill, they do the same thing. What they do is it's kind of not the same thing. Matter of fact, I'll skip that. I'll come back to it because it probably fits better, I think, for the next one. So, number of particles. So now, number of particles. What you do to the number of particles is going to affect the pressure. So let's go back to that, where your tank of propane, you can go to a place in town, you can watch them, they can actually fill it full of the gas for you. And what they do is when they fill up the tank, they're adding more particles of that gas. And so remember, it always picks up. It's more striking the container, and then the pressure is going to increase. But if you remove some of the particles, the pressure is going to decrease. Kind of just the opposite there that it is here. Pretty easy to understand. You guys are pretty basic. You know, you get the idea. You've probably had to deal with this stuff here. If you let out some air in your tire, right, you're going to decrease the pressure. Look what happens. You get a flat tire. But when you want to fill up your tire, you're going to add more oxygen particles or air particles to it, and that's going to increase the pressure, and that's going to make the tire stand up. Okay, those we will go over later.